Today I'm going to talk to you about turning mixed numbers into fractions greater than 1 and fractions greater than 1 into mixed numbers. But first, let's talk about what each of those are. A mixed number is a number such as, let's go with 1 and 3/8. It's called a mixed number because part of it is a whole number and part of it is a fraction. And so it's mixed because it has two different parts to it, a whole number and a fraction. A fraction greater than 1 is also often called an improper fraction, but that's actually something that is kind of a misnomer because they're not bad, they're not improper, there's nothing wrong with them. They're just a different way of viewing a fraction. So a fraction that's greater than 1, you can tell a difference between a regular fraction and a fraction greater than 1 because of the order that things are in. For example, 3/7 is a regular fraction because the numerator is less than the denominator. However, 7/3 is a fraction that's greater than 1 because the smaller number is in the denominator. So if you ever want to tell if a fraction is just a regular fraction or if it's a fraction that's greater than 1, you look for where the bigger number is. If the bigger number is on top, the fraction is greater than 1. If the bigger number is on the bottom, the fraction is going to be somewhere actually between 0 and 1. So let's first work with turning mixed numbers into fractions greater than 1. This right here, this means mixed number, and this is a fraction greater than 1. So that's just my abbreviation for writing them. So a mixed number and a fraction greater than 1. So 2.5 is a mixed number. It can be separated and broken down. I first want to talk to you about why turning it into a fraction greater than 1 works, and then I will show you a faster method for it on the next slide. So 2.5 can be broken down into 2 plus 1/2. These can be separate parts. And the 2 can be broken down even farther into 1 plus 1 plus a half, because 1 plus 1 is 2, and then the half is there attached onto the end. Now, I'm going to turn these ones into a useful form for us. We know that a multiplicative identity, such as 2/2, is the same thing as a giant 1, because 2 divided by 2 is equal to 1. And in this case, I specifically chose 2's because the denominator of our fraction is a 2. And so I wanted to have the same denominator on all three parts. Technically, you could have different denominators, but it makes this next part not make quite as much sense. So if I were to draw these three fractions out, I would have 2/2 plus 2/2 plus a 1/2. And altogether, I have 5 parts shaded in, and they're all split into 2 even parts. So we started with 2.5, that's our mixed number, and the fraction greater than 1 is 5/2. Now we know that we've got this correct and in the correct order because the big number is on top, and that is what we want for a fraction greater than 1. Now there is a faster way of doing this. It's just an algorithm, but I wanted you to really see and know where this came from. You can do 2 times 2. You can do this multiplication, so 2 times 2 is 4, and then add this number up here. So we would do 2 times 2 plus 1. It always goes in this same order, the denominator first, times the whole number over here, plus the numerator on the top. So 2 times 2 is 4, and 4 plus 1 is 5. This gives us that 5 that we were looking at earlier, and our answer is 5/2. So the numerator is the answer to this problem, and the denominator, it actually stays the same. The denominator doesn't change at all. We use the one that was over here to begin with. So let's try this on one more. We always start with the denominator and multiply it by the whole number, so that would be 8 times 3. And then for the second part of this, we add the numerator, plus 1. 8 times 3 is 24. 24 plus 1 gives us 25. Now this is something that I do expect you to be able to do in your head. If you can't do it in your head, you want to write it out, that's fine, but if you can do it in your head, you do not have to write all this steps out. You can just simply say 3 and 1/8. You can say, I know that 8 times 3 plus 1 is 25. And then don't forget we keep the 8 in the denominator, so that would be 25/8. Alright, so let's talk about going the other way. If we have a fraction greater than 1 and we want to turn it into a mixed number, I'm going to show you the breakdown first so that you understand what's happening, and then I'll show you the algorithm again, just like we did going the other way around. Remember, this means fraction greater than 1, and this means mixed number. So 13 thirds means that I have something that is split into thirds. That's why I'm using 3 boxes, and I have 13 of these boxes that are shaded in. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pieces that are all worth 1/3. Now if we look at this in terms of whole numbers, we have 1 whole here, 1 whole here, 1 whole here, and 1 whole here. 1 plus 1 plus 1 plus 1 is 4. And then don't forget we have this extra 1/3 over here. So 13 over 3, the fraction greater than 1, is equivalent to 4 and 1/3. So that's the reasoning behind this and what's happening. We took this denominator of 3 and we created thirds, and we shaded in 13 of them. And then by counting how many wholes we have and how many leftover pieces we have, we were able to create the mixed number. Now here's a standard algorithm that most people use. Most people use division, because remember that this fraction bar means that we can divide. So we would start with 13 and divide it by 3. The numerator goes on the inside and the denominator goes on the outside. That's very important. Hang on, I have to sneeze. Oh, it's not going to come today. All right, so you would ask yourself, excuse me, sorry. Would ask yourself, how many times does the number 3 fit into the number 13? The closest we can get is 4 times, because 3 times 4 is 12. If we subtract, we get a leftover of 1. Now, that leftover, if we were to continue the problem and use our answer, get our answer in decimal form, we would add a 0 to the end of this and we would bring down the 0, but that's not what we want to do when we're turning it into a mixed number. When we're turning it into our mixed number, the remainder is the numerator, and the number that we were dividing by, the original denominator, stays the same all the way over here. So we got 4 because 4 3s could fit into 13, and we would have 1 left over, so that makes 1/3. This matches our answer that we just got on the previous page of 4 and 1/3, so we know that it works. Just one more quick example. If we do the same thing, numerator divided by the denominator. 7 goes into 26. It can fit a maximum of 3 times. 3 times 7 is 21. And if we subtract, we get a remainder of 5. That remainder goes in the numerator, and the denominator stays the same. So 26 sevenths is equal to 3 and 5 sevenths. Now this is also something that I am okay with you not showing this whole division process if it's something that you can do in your head. However, I know that a lot of you are still getting used to division into remainders, and so I recommend using it until you are very comfortable with it. But that's your choice. As long as you can create this equivalence statement, you're good to go. So here are just a few quick practice problems for you to do. These 3 problems over here, you're going to turn them into fractions greater than 1. And these 3 problems over here, you're going to turn them into mixed numbers, and then just answer this last one right here. All right, I will see you in class.